first example of proving trig identities is tangent of A plus cotangent of A is equal to cosecant of A times secant of A. In order to prove this identity, you should choose one side to work on, generally the more complicated side, but in this case it does not matter which side you choose. Let's pick a side. The first step on working on the side is to substitute tangent of A to sine of A over cosine of A, and to substitute cotangent for cosine of A over sine of A. We can do this because of basic trig identities. Because we know tangent of A is equal to sine of A over cosine of A, and cotangent of A is equal to cosine of A over sine of A. Now that we have two fractions, you have to make them have a common denominator in order to simplify them. So I multiplied sine over A over sine over A times sine of A over cosine of A, and multiplied this part, cosine of A over sine of A. Multiply this part by cosine of A over cosine of A. We're allowed to do this because sine over A and sine over A is equal to 1, and same with cosine of A over cosine of A. So now we can simplify this part. Sine of A times sine of A is sine squared of A over sine of A times cosine of A. And cosine of A times cosine of A is cosine squared of A over sine of A times cosine of A. And now that we have these two fractions with common denominators, we can combine them. So sine squared of A plus cosine squared of A all over sine of A times cosine of A. Okay, now using the Pythagorean identity, we can substitute sine squared of A plus cosine squared of A with 1, because sine squared of A plus cosine squared of A is equal to 1 according to this Pythagorean identity. So 1 over sine of A times cosine of A. So now we're basically done with this side. Now we have to go back to the right-hand side of the equation to make it look like this left-hand side of the equation. And because we know that cosecant of A is equal to 1 over sine of A, and secant of A is equal to 1 over cosine of A, we can change this part of the equation to 1 over sine of A times cosine of A. And because these two sides match now, the identity is proved.
Here is a second example of how to prove a trig identity. So we have secant theta over cosine theta minus tan theta over cotangent theta equals 1. We're going to start on this side because it's the more complicated side. So first, we can change secant theta to 1 over cosine theta. And we're going to bring down the cosine theta here. And this simplifies to 1 over cosine squared theta. And we can rewrite tan theta as sine over cosine. So sine theta over cosine theta all over cotangent theta. And we know that cotangent theta equals cosine over sine. And we're going to bring 1 over cosine squared theta, bring it down again. And to divide this, we're going to multiply it by the reciprocal. So we have sine theta over cosine theta times, and here we're going to do the reciprocal, so it is sine theta over cosine theta. And we're going to bring this down again. So we have 1 over cosine squared theta minus, and this becomes sine squared theta over cosine squared theta. And we can also rewrite this sine squared theta over cosine squared theta as tan squared theta. And we can rewrite 1 over cosine squared theta as secant squared theta. And then we're going to bring down the equals 1. And now what you can do is, to get secant squared theta by itself, you can add tan squared theta to both sides. And you get secant squared theta equals 1 plus tan squared theta. And this is also a trig identity. And so, since we know that secant squared theta equals secant squared theta, which is the same as 1 equals 1. And therefore, we have proved it.
So for this third and final trig identity, we have tan squared x times sine squared x equals tan squared x minus sine squared x. And I'm going to start on this side. And usually you would want to change your tangents into either cosine and sine. So I'm going to turn tan squared x into sine squared x over cosine squared x, still minus sine squared x. So now that you have a fraction, it's probably best to change sine squared x also into a fraction. So what I'm going to do is I'm going to multiply sine squared x by cosine squared x over cosine squared x, which you can do because that equals 1. And that way you have a common denominator of cosine squared x. So now you have sine squared x over cosine squared x, subtract by sine squared x times cosine squared x over cosine squared x. And now that you have this common denominator, you can put it all over one fraction. Sine squared x minus sine squared x times cosine squared x, all over cosine squared x. And now you can see that you have a common factor of sine squared x. So you can distribute this out, which will give you sine squared x times 1 minus cosine squared x, all over cosine squared x. And now that you have these two terms multiplying instead of subtracting, you can divide sine squared x by cosine squared x, which is also equal to tan squared x. Multiply 1 cosine x. And now using the Pythagorean identity that says sine squared x plus cosine squared x is equal to 1, you can manipulate that into proving sine squared x equals 1 minus cosine squared x. So you have tan squared x times sine squared x, which is the same thing here. So you've just proved it.
How about the first step?
We're going to start.
You!
I'm laughing. It's shaking. The phone is shaking. I can't contain my laughter. My handwriting sucks, guys.
Since we know that sorry.
Change sine squared x into, oh damn it.
Let's go. I need to get into character. Okay, I'm ready. Ready, set, go. I'm not ready.
They do the Harlem Shake.